In this tutorial, I'm going to show you how you can add a Verilog testbench file to your project and use this Verilog testbench to simulate your design. When you first created the project and added your design file, the file shows up under the Design Sources folder of the Project Manager Sources window. This folder of the design sources includes those files that will be used as part of synthesis in generating logic that will be downloaded onto the FPGA. Your design files are also added to another folder called simulation sources. As shown here, my 7-segment file, Verilog file, is going to be used for simulation. Your design sources generally are always added to your simulation sources because I want to simulate the file that I also want to synthesize. In many cases, we will be adding Verilog testbench files to our projects. Verilog testbenches are unique Verilog files that are not used for synthesis, but are used for simulation. They provide stimulus and also design checking for our Verilog files to help us make sure that the files are operating properly. I'm going to demonstrate how you can add the testbench file to your project. We do that just like we've added other files. We add sources, but in this case, instead of adding design sources, which are sources that are synthesized, we're going to click the checkbox Add or Create Simulation Sources. These are files that are added only to the Simulation Sources folder. So I add the file, 7-segment testbench, finish, and as this will update, and as you'll see here, that the testbench shows up under simulation sources, but does not show up under design sources. You'll also notice that the 7-segment design file is shown underneath my 7-segment testbench file. This is because 7-segment Verilog file is actually instanced inside of my testbench file. You'll also notice that the TB 7-segment file, it has a bold on it with this little icon. This means this is the top level that will be used for simulation. The simulator, when run, will run the testbench file, which instances my 7-segment file. Sometimes I may not want to use the testbench for simulation, and if that's the case and I want to simulate my 7-segment file by itself, I select it, right-click, and select Set as Top. What that means is that when I run the simulation, the 7-segment module will be simulated without the testbench. Since I want to simulate the testbench, I'm going to select the testbench, select it as top, so that when I run simulation, the testbench is run. Now that the testbench has been added to my project and is selected as the top, I can simulate it as usual using the Run Behavioral Simulation. Okay. In the simulator, you will see, as usual, we have our waveform window, our scopes, and our objects. You'll notice, though, that there are actually two items in the scopes. There's the testbench and the 7-segment display. In this waveform window, all of the signals in the top level testbench have been added. Sometimes I want to see the signals inside my 7-segment display. And so in addition to these signals, I can add a divider. This divider will separate, and I can name it. And then after the divider, I can select my 7-segment module and add these signals to the simulation window. At this point, I can simply type run. The testbench has been designed to provide a stimulus, so I do not need to run any force commands in Tickle. I'll simply run for 1 microsecond, and the testbench has provided the stimulus and has completed the simulation. You'll notice in this simulation that the testbench provides an output. It says the start of simulation, and it gives me some data, some feedback telling me when there is when it's operating correctly, and then it says it's done without any errors. So my simulation operated correctly. In many times, the simulation will show, give me times. It'll say 440 nanoseconds. I can actually find this. If there's an error, I can actually find the error in the waveform. So if I want to find out what happens at 400 nanoseconds, I click on the waveform window, right-click, and select Go To. With Go To, I put in the time, 400 nanoseconds. That tells me what's going on at this time, and I can see my 7-segment operating correctly at 400 nanoseconds. In this example, I want to demonstrate how you can find errors and debug your errors from the test bench. So I've gone back and modified my 7-segment decoder and added an error. So I'm going to run the simulator for 1 microsecond as in before. You'll notice that I have some errors. Error with data on input 0xc, segment 6 should be a 1 but is a 0 at time 560. So let's see if we can go find that error. I can go to my waveform, I'm going to zoom out, right click, select Go To, and in this box I'm going to type 560 nanoseconds. Okay, this takes me right to where my error is. I can zoom in, and as it shows here, I'm trying to display the segment C, and my segment's outputs are 0, 6. As you can see here, a 0, 6. But it tells me that segment 6 should be a 1, but is a 0. So I need to fix my logic for this example.